Alright, trig class, let's look at one of these examples of a trig equation when the input is not just theta or x. We have a whole entire expression in there possibly. Alright, so here's what we're starting with. The sine of 3 theta equals -1. Now, this is what is inside the sine function. So I'm just going to treat it like it's an angle. Like if, some Greek letter, you typically use Greek letters for these. You can use anything you want, but this is the Greek letter alpha. If alpha is 3 theta, this would just say the sine of alpha equals -1, which means, whatever this angle is, the y coordinate there, remember sine is the y coordinate on the unit circle, the y coordinate there is -1. That's what that phrase says for this angle, or whatever alpha happens to be. So I'm going to look on the unit circle, and I'm trying to find where is the y coordinate -1. So there it is. It happens right here at 3 pi over 2. So that's not our solution, that's what alpha is. Alpha is 3 pi over 2. That's an angle that works. Right? But it would also work if I added 2 pi to that as many times as I want to. So 2 pi times k, where k is some whole number. All right, now alpha is not what our original equation was. It was 3 theta. So what I'm going to do is replace this with 3 theta. And now I have 3 theta has to be 3 pi over 2 plus some multiple of 2 pi. And now I'm going to isolate theta because ultimately that's what I'm trying to do. I'm trying to divide away the stuff on the inside so I can have, the solution here would be theta equals something. That's the unknown in the original equation. So I'm trying to isolate theta, so I need to divide away this 3. Well, 3 pi over 2 divided by 3, that 3 and that 3 are going to cancel, so that's just going to be pi over 2. But I also have to divide this part by 3. So my solutions are going to be of the form pi over 2 plus 2 pi over 3 as many times as I need to, and this is going to be what determines how many solutions I actually have. Like on the unit circle, there's only one time where we hit -1. But because we're tripling the angle, there could be multiple angles that make this work. So we know pi over 2 is going to be one of them. But if we add 2 pi over 3 to that one time, we should get another one that works. So common denominator here would be 6. So that would be, to have a 6 down here, I had to triple that. So I need to triple the top 2. So I'll have a 3 pi over 6 plus, and then having a 3 down here means I'm going to have to double the 2 pi, which would be a 4 pi. So 3 pi over 6 plus 4 pi over 6 is 7 pi over 6. And notice 7 pi over 6 is in our unit circle. All right? And now we need to add 2 pi over 3 again. All right? It's 2 pi over 3 k times. So we're going to add it again to 7 pi over 6 to see, do we hit it a third time? So pi over 2 works, 7 pi over 6 is going to work. And now we add 2 pi over 3, which is the same as 4 pi over 6, to 7 pi over 6. So 4 pi over 6, 7 pi over 6 is 11 pi over 6. That is also on the unit circle. All right, so there's a third place where this could happen. So our solutions were pi over 2, 7 pi over 6, and 11 pi over 6. So it has this kind of shape to the angles that work. All right, notice pi over 2 is the same as 3 pi over 6. So 3 plus 4 is 7. 7 plus 4 is 11. So there's like a little pattern going on here. It's just this one reduced. All right, there are our 3 solutions. All right, let's also see that we can do a little bit of this on the TI calculator. So once I have the pi over 2, if I remove the pi, we've talked about this before, if I remove pi, and then I add, instead of 2 pi over 3, add 2/3. Again, taking the pi out of these equations, turning them back into fractions, and sticking the pi back in there, I get the next one. And then add to that 2/3 again, turning it back into a fraction. And there's the 11 pi over 6. Okay. Now another thing you could do is type the left and right hand sides as y equals the left hand side. So sine of 3, you have to use x. Notice it says xt theta n. So it's like any of those variables, you can just click that button. It's going to use x, but it's the same thing. Sine of 3 theta equals, and then y equals -1 For the next one, all right, I'm going to do zoom trig. I may have to zoom this back out. So there's our sine of 3 theta. There are the negative ones. And then let me actually do window and make my y's go between negative 1.5 and positive 1.5. Now we're looking just between 0 and 2 pi. So I could adjust my window again and make that 0, the x minimum, make this 2 pi x maximum, and then I can do maybe like pi over 6 as my step size. So for those tick marks. Now how could I use that? What would be the benefit of doing that? Well, the tick marks are pi's over 6's, right? So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So there's that one. 8 pi over 6, 9 pi over 6, 10 pi, 11 pi over 6. I can see based on that. But again, I would have to know to make my step size pi over 6. I would almost have to know the solutions have pi over 6 in the denominator. All right, but because that is the smallest denominator on these special fractions, pi over 6, and then that's 2 pi over 6. These are, several of these are multiples of pi over 6. That is a good thing to make when you're doing a calculator to kind of help you if you kind of don't know how to proceed. Pi over 6 is a good thing to make your x scale on these trig equations.